So in this video, we will go over some stuff about radicals, and more specifically, denesting radicals. So before we investigate what the term denesting means, we have to look at what nested radicals are. So nested radicals, oh, that's not a nice straight line. Nested radicals are essentially radicals inside of radicals, or like a radical expression inside of a radical. So, for example, like square root of 5 plus 3 times square root of 2, or like, it doesn't have to be specific numbers, it can be like variables. So like a radical expression written inside of a radical. And these are really annoying to deal with because if you have a radical inside of a radical, you have to keep squaring them or like repeating all the techniques you use. And like sometimes when you square things too many times, it becomes very it becomes very complicated and overly complicated than how you're supposed to solve the problem. So by denesting, so to denest is to convert these sort of nested radicals into the form square roots of x plus square roots of y, where x and y are integers. So essentially what we're doing is we're trying to reduce it into only having one radical. So we no longer have nested radicals. So nested radicals where we have a radical inside of a radical. We kind of freed it into an easier expression. So this is a much easier expression to deal with than these sort of nested radicals. So we're going to look at how to do these. And actually there are specific forms of these that we cannot denest. And we might go over that. We might go over that condition in another video. So, but to get into this, so what we're trying to do is we want to put a radical expression in the form of square root of a plus minus b into the form square root of x plus minus square root of y, and a, b, x, y are all integers. Yeah, it is important that these are integers if they're real numbers. So if in this case, like if it was x and y are real numbers, then it wouldn't work. The method we're using is not going to work. So I'll show you how to do this now. So just explaining it in general doesn't make sense. So I'm going to do an example problem to make it more clear for you guys. So our example problem is denesting square root of 4 minus square root of 2 minus 2 times the square root of 3. So we want to put this in the form of this, and we'll realize that if this is a minus, then this is going to be a minus. If this is a plus, if this is going to be a plus. In this case, it's a minus, so it's going to be in the form of this. And you realize why. You'll realize the reason for the correspondence if you try enough problems. You'll see a pattern, and you'll kind of intuitively know why. So we're going to square both sides to get rid of this radical. So this side will be this. So we're just putting it in this form initially, and then we're going to find what x and y are, which is a clever trick. Because this is a common trick in math problems. If you want to put this in the form you want, then you put it in the form, and then you find the variables in it. So you square both sides, and then this side becomes x plus y minus 2 root xy, and then we're going to group the terms together. So we're going to group the terms together. So we're going to look at the integer part, and then we're going to look at the irrational part. Okay, irrational part. And this is because if you look here, this is the number inside of the radical is an integer, but it's not a square number. So this is going to be irrational. It's not an integer, but these are integers. So we can group the integers together. Okay, wait. So we can equate the integers separately to each other, and then we can equate the radical parts separately to each other. this is legal because we're dealing with integers. But if x and y were, if these were real numbers, if these weren't integers, then it would be a different case. We won't be able to freely do this. But since it's integers, it's really specific numbers, so it works. So we're going to equate, so we get a set of simultaneous equations, x plus y is equal to 4, and 2 times square root of xy is equal to 2 times square root of 3. And then this just means that x times y equals 3. So you can simultaneously solve them, like using your substitution methods or something, but by quick observations, we can just realize that the only solution where x and y are integers would be where x is 3 and y is 1, or y is 1 and x is 3. But this doesn't work because if you look here, the equation didn't specify plus minus in front of the radical, and if it doesn't do that, then it means the radical is positive. So this must be positive. So this must be positive. If y is 1 and x is 3, then this would be negative, which is illegal. So when we square a radical, you must remember when we do squaring while solving radical equations, then we forget, in the midst of our mathematical reasoning, we forget that the plus minus condition. So whether something can be negative or not, because if you square negative, it becomes positive too. So you must always plug it back in and see if it's possible. So the answer would just be x is 3 and y is 1. So therefore, denested, this would just be square root of 3 minus 1, which is pretty nice. It's much nicer to deal with, and also this became an integer, which is also very good. So yeah, that is how you denest radicals, and we can actually try another problem, maybe with a plus, I think, to get the hang of this. So I'll just erase this. I'll just erase this part so that we can refer to these things. So the next problem, let's say, is square root of 10 plus square root of 2 times square root of 21. So I'll just recommend you to stop this video and try this problem on your own, and then look at the solution together. So the solution would be, again, the same as last time. We put this as this, but this time it's a plus, so we put a plus here. We square both sides. And again, we group the terms. We group them together, and then we get a simultaneous set of simultaneous equations. I'll just do it straight away, because 2 roots 21 is equal to 2 root xy, so xy is equal to 21. And then a solution would be xy equals 7, 3, or 3, 7. But we realize that it doesn't matter, because square root of 3 plus square root of 7, or square root of 7 plus square root of 3 is basically the same expression, just ordered around differently, but ordering doesn't really matter. So therefore, we have found that this is denested. This would just be equal to square root of 3 plus square root of 7. That was pretty neat. So that was about denesting radicals. So actually, this might seem like a very common technique, but in junior competitions, you don't really see it. But throughout doing a wide range of competitions, it is possible. There are still cases when these kind of problems come out. So it's good to know how to do this. But then also, it's not the method itself that you must remember and just have this in your mind, so that you can just use this specific technique, this whole technique, whenever you see these kind of problems. It's all about just learning from these kind of methods. So we learn like a tactic where we just put it in the form we want so that we can put it in that form later, or like how we can group the integers together and the radical parts like that. So it's all about what you take away from the method, not about having this method in your mind so that if this kind of problem comes up, you can just solve it straight away. Well, that would be good, but it's good to take away things that you can apply to a wide range of problems. So yeah, that was it for today, denesting radicals, and I hope you enjoyed this video, and see you in my other videos.